MRI scans the gold standard for the diagnosis of acoustic neuromas?
So we know that in order to diagnose an acoustic neuroma, you need to obtain the proper imaging study. And at present, this would be a high quality MRI scan, typically done with contrast dye. MRI scans were developed in the early 1980s, and over the last several decades, the image quality of the MRI scans has increased over time to the point that now we can obtain very detailed images of brain anatomy, including the inner ear where acoustic neuromas reside. The acoustic neuromas have very classic MRI characteristic findings that allow them to be diagnosed. Number one, we know they typically enhance with the contrast dye given. The contrast makes acoustic neuromas light up as a white structure in the surrounding dark gray brain and bone. In addition, we know that acoustic neuromas appear right outside the surface of the brain, but inside the skull, and they have a very specific location in the inner ear. Anatomically, we as neurosurgeons call this location the cerebellopontine angle or the CP angle, and acoustic neuromas occur in this location. So you may commonly see them referred on MRI scans as a tumor in the CP angle. So MRI scans can be subsequently used to follow the tumor over time, either before or after treatment, to assess for any changes. And what we're looking for in the MRI scan is any change in the actual size of the tumor by physical measurement, or any change in the structure within the tumor, the development of cysts or other lack of contrast uptake that typically is associated with necrosis in a treated tumor. In some instances, MRI scans can be done without contrast once the size and shape and location of the tumor has been fully evaluated.